Hello guys. Hi guys, how are you? Okay guys, quickly tell me how many centers are there? Every center. Okay, Satna is there. Okay, Shillong. Are you there guys? Shillong. What are you doing guys? I have got only one response. That is from Satna. Shillong, yeah, that's cool. Shillong is present. How many students are there at Shillong Center and at Satna? Give me a quick count. All the centers with number of students. Give me a quick count. Until now. Okay. Okay, Shillong. Good. So guys, first of all, tell me what are we discussing in the last class, and is there any doubt that we have discussed in the last class? Anything that you want to ask me again that I have taught you in the last class? Okay, that's cool. So I think we were discussing about the Bohr's model of atom, and we have derived the relation of energy in the last class. Actually, we had two relations. First relation was for the radius of nth orbit, which is Rn is equals to 0.529 n square upon z angstrom, whereas the second relation was for energy of stationary orbit, which is En is equals to, okay, I think we have discussed the ratio of kinetic energy, potential energy, and which energy? Guys, there were three types of energies that we have discussed in the last class. First of all, tell me that is this relation has been discussed in the class or not? This is kinetic energy, potential energy, and total energy. In the last class, we have discussed ratio between them. And tell me, is it discussed or not that En is equals to minus 2.18 in 10 to the power minus 18 z square by n square? Okay. I think we haven't discussed any questions. And one more relation for this. This is for the joules. When energy is in joules, this was joule per atom. And the second relation was minus 13.6 z square upon n square. This is electron volt per atom. I think we have already discussed about it. These relations we have discussed in the last class, okay? But we haven't discussed any questions based on these concepts. So guys, today, first of all, we will discuss about the questions regarding these concepts, and we will proceed after that, okay? So these are the formula. Ultimately, you have to use the formula. So guys, let us begin with few questions. Here we comes with the question number 1. First of all, you have to attempt this question, and after that, you have to just put the formula. And I hope so everybody is clear with the points that, look at this, here N represents the orbit, ultimately in which orbit electron is present, and Z is your atomic number. This is your atomic number that would be different for different atoms. Okay? Now, this is the question number 1. Calculate radius and energy of second Bohr's orbit of hydrogen atom. Okay guys, this is the first question for you. I'll solve this first question for you. Okay, you have to clearly understand the concept that how do we put the formula, how do we'll use the formula. Okay, and after that the next question will be for you. Okay guys, remember one thing, all these questions and the concepts are already written in books. Okay, so our concern is to understand the concept behind the everything that we are discussing over here. So guys, make sure while we are understanding the concept, nobody will write anything. They will clearly look at the board on the screen. They will understand the concept only. After that, I'll give you some time to note that, to copy it. Okay? Nobody will write with me while I'm writing for you. Is it clear to everyone? Guys, is it clear to everyone? That you have to understand the concept only. After that, you would be able to solve the questions. Okay? So, like, this is the first question. This is quite simple. So, first of all, we have to calculate the radius. We know that formula for the radius is 0.529 n square upon z, angstrom. Guys, look at this. Here, the atom is hydrogen. So, for hydrogen, Z will be 1 because atomic number of hydrogen is 1. Now, here, they are talking about the second orbit. It means the value of n will be 2. Now, you have to just put these values and you have to solve it. So, if I solve for, let's say, suppose second orbit, because they were talking about the second orbit, it will be R2. You will say 0.529 n, which is 2. 2 square upon 1 angstrom. Now, it will be 0.529 into 4. So, it will comes out to be 2.116 angstrom. So, this is the answer for the second Bohr's radius. Any doubt for this question, for this particular part? Anybody has got any doubt? Cool. So, first of all, okay, note it down. Okay, no, first of all, look at this. We have to calculate energy as well. See, we have to calculate energy. Guys, remember one thing in the question, it is not mentioned that whether we have to calculate the energy in the electron volts or in the joule. So guys, in that scenario, we will always calculate the energy in joules until unless it is mentioned in the question that you have to calculate the energy in electron volts. You will always use the standard unit, which is SI unit of energy, which is a joule. Okay. So here we will calculate the E2, which is equals to minus 2.18 into 10 to the power minus 18 Z square, which is 2 square upon N square, which is 1 square. Okay, just a second. Just reverse it. Z square, which is 1 square, upon N square, which is 2 square joules. So it will be minus 2.18 into 10 to the power minus 18 upon 4. So when you will solve it, we'll find out that this is 0.545 into 10 to the power minus 18 joules per atom. Guys, anybody has got any doubt? Anybody has got any doubt regarding these two parts? Shillong? Satna? Okay. So guys, now you can note it down. You can note it down. Sisipur, you were late. Itanagar, when you have started? Okay, I'll share with you. Guys, have you noted it? Guys, have you noted it? Okay. Note this one as well. And I'll give you second question. Yeah, that's cool. Okay, I'll start with the Shillong Center. Shillong Center will show its presence with the name on the chat screen. Everybody, at the Shillong Center, only Shillong Center. After that, I'll catch one by one other centers as well. Shillong Center can start. First of all, you have to note it, and then everybody will introduce itself by their name. Okay. So guys, this is the next question for you. Shillong Center, I would like to know the name of the students. I mean your name. So one by one, you can write your name on the chat screen. Okay? One by one. Okay, Florence, Daniel, guys, I'm writing second question for you. Shillong, yeah, Sweetie, Vidalin, Precious, Sonal, calculate energy and radius of fourth Bohr's orbit of He plus ion. Okay, guys, here's question number 2 for you. You have to solve it for me and you have to tell me the answer. Okay, so we have got Sonal, Sonam, Lisa, Gibson, Feba, Shan. Over? Four days ago. What? What Itanagar? Acha, okay, 4 days ago. Itanagar, we have discussed the concept we have started the concept in the last class. I'll share. Anybody else in the Shillong Center who is left? Everybody has spoken their name. Okay. Eliezer. Okay, that's cool. Okay. So now, guys, you can start. Do this question for me, guys. Do this question for me. Okay, Itanagar. Itanagar, next turn is yours. How many students are there at the Itanagar Center? How many students? Give me a quick count for the Itanagar Center. Itanagar, I am asking about the number of students at your center. The students will solve these questions. Oh, this question actually, not questions. Oh, what is this? Okay. We have got one answer. Okay, so Itanagar, you can spoken there your name. Number of the students who are present at the Itanagar Center. Write your name on the chat screen. Satna has got the answer. Shillong, have you got the answer? Okay, guys, let's take a look. Have you attempted, Shillong? Have you attempted this question? Or you still need some more time? Itanagar, I am asking for your names, guys. Introduce yourself. Okay, do it. Itanagar. Okay, Satna has got the answer. Cool. Satna, how many students are there at your center? How many students are there at your center? Okay, you have got the radius. Cool. I am okay. Taba. And who is the other one at the Itanagar? Satna. Spoke your name. What's your name? The student at the Satna Center. Guys, am I visible to everyone clearly? Am I visible to everyone? Okay, Jia. Okay, this is another answer. Okay, that's cool. Okay, so guys, let's solve this question. I think quite easy this question. C. Okay. So guys, we have to calculate the radius and the energy. First, we'll calculate the energy, En. We can put at the place of n 4 because they were talking about the fourth orbit. So here it is 2.18 into 10 raised to power minus 18 z square by n square. See, this is the helium atom. So for the helium, atomic number is 2. So we will say it is the 2 square upon fourth orbit means 4 square. Okay, joules. Now it will be 2.18 into 10 to the power minus 18 into 4 upon 16. So you can, okay, I got you, Itanago. 4. So when you solve it, you will get 0.545 into 10 to the power minus 18 joules. This is the energy. This is the energy that you have got. I think many students have got the right answer for the energy. Other students who haven't got the right answer can note it down. Note it down, guys. Can we proceed? Have you done, guys? Any doubt? Okay. So let's do the next part where you have to calculate the radius, which is 0.529 n square by z, which is 2 square upon 4 angstrom. Oh, just a second. Let me check it again. The fourth orbit. Okay, fourth orbit. Cool. So this is 4 square upon 2. So this will be 0.529 into 8. So actually you will get just a second, guys. Okay, guys. So answer is yeah, this is the not 4.3. This will be 4.232 angstrom. Congratulations to all those students who has got the right answer. Okay. So guys, okay, Shillong, raise your hand once. Who has got the right answer? Both the answers are correct at the Shillong Center. I can see you guys. Okay, cool. Okay, guys, this is one type of questions. One more important thing, the next concept. Guys, look at this very carefully. See, in the Bohr's fourth postulate, we have discussed, guys, this is the new concept, that delta E is equals to E2 minus E1. Okay? And we know that E2 can be written as minus 2.18 into 10 to the power minus 18 Z square upon N2 square minus 2.18 into 10 to the power minus 18 Z square upon N1 square. Guys, look at this formula very carefully. That was the Bohr's fourth postulate. See, when you solve it, this negative and this negative will become the positive when you open the bracket. So this whole value will become positive. See, Z is common over there, so I can take the common out of here, as well as 2.18 in 10 to the power minus 18 is also common. So we can write it like this. 2.18 into 10 to the power minus 18, 1 upon N1 square minus 1 upon N2 square. Here it is Z square. Okay? Now, this is equals to delta E. Now, in the Planck's quantum theory, you have learned that this delta E can be written like that. This one is hc upon lambda. Okay? H is a Planck's constant, which is a fixed value. C is the speed of light. Now, if I solve it for the lambda, 1 by lambda should be equals to 2.18 into 10 to the power minus 18, 1 upon N1 square minus 1 upon N2 square into Z square upon HC. Guys, remember H is constant, C is also constant. So when you solve whole this value, you will again get a constant, and that constant value is this one. 109,677. That you have to remember. 1 upon N1 square minus 1 upon N2 square into Z square. So this is our required. Just a second, dear. This is our required new formula. Yeah. So we are new. Can you tell the topic related to all this? Dear, we are discussing about the Bohr's atomic model. Bohr's atomic model. If you have joined in the last class, so I'm continuing the last class actually. I'm driving the relation of the Bohr's model. Other students, guys, have you cleared the concept? Guys, have you cleared the concept? Or any doubt regarding this one? Students? Guys, you can note it down and give me a quick reply that is there any doubt regarding this relation, regarding this derivation? No is for what? This. Guys, you have to just reply clear or not clear. Okay, that's cool. We have derived one relation. Now, we will discuss that where do we have to use this relation? Where do we have to use this relation? So we need the formula. Which formula, dear? Eta Nagar? Which formula are you asking about? I have started with this one. You have to remember this formula. So guys, can we proceed? Anybody want to ask anything regarding this one? Itanagar, kindly write your doubt clearly. I'm not getting you, dear. What do you want to ask actually? Other one? Any other guys want to ask anything? Okay, guys. Sir, how to Dear, first of all, you have to tell me that how many classes you haven't attended till now. Okay, guys. Look at this. This is an atom. And suppose this is the electron. Okay. See, when electron changes its state, I mean, it jumps from its orbit to another orbit. Obviously, it will absorb some energy. Okay. And when it returns from its excited state, see, when electron jump from lower energy level to higher energy level, that higher energy level is known as the excited state. So, when electron comes back, okay, just a second, guys. So, previous question which we have solved. If you are talking about this one, Itanagar, this is a relation, not a question. And if you're talking about this one, this question, that I have discussed the formula regarding this in the last class, as well as in the beginning of the class, I have written the formulas that I have taught in the last class. Okay. Any other thing, Itanagar? Can we proceed? Guys, right now you have to just use the formula that I have discussed with you. That's it. If anything that you have missed, text it on the chat screen. Dear, you are writing the same thing again and again. Itanagar. This is question number 1. This is the question number 2. Tell me which question you are talking about. And this is the energy relation. Oh, guys, one more thing. This formula is known as Rydberg formula. Remember this one. This formula is known as Rydberg's formula. Rydberg's formula. You have to note this one as well. That this one is the Rydberg's formula. Now we'll discuss where do we have to apply this formula and why do we apply this formula. Guys, copy it that this is the Rydberg formula. Okay, let's move on. So I was discussing about this one, that whenever an electron jumps from lower energy level, see, this one will be n equal to 1 and this one will be n equal to 2. Okay. So this is the lower energy level. This is your lower energy level. And this one is your higher energy level. Higher energy level. Kohima, are you there? Okay, guys, see, I have told you that whenever electron, see, this is the electron, whenever electron jumps from lower energy level to higher energy level, this is what we call, see, higher energy level is also known as the excited state. Excited state. Okay. So guys, during the transition, this is the process that we are discussing about right now, that when electron changes its own orbit and goes to another orbit is known as the transition. So during the transition, obviously it will gain some energy. Okay. And if it gains some energy, we know that energy is equal to hc by lambda according to Planck's quantum theory. Okay. So obviously, if electron gains some energy, it will definitely have some wavelength. Okay. And whenever electron jumps from higher energy level to lower energy level, obviously it will lose some energy. So in every case, energy is related with it, and energy always have the wavelength. Okay. Or we can say, this is another formula, which is h nu. It will have certain frequency. So guys, we can say this is the E1. This is your E1. One second. Lower energy level, we are designating it with E1, and this one is your E2. Okay. So if I talk about the change, you will say change is equals to what? E2 minus E1, and which is equals to what? Delta E. So guys, this is the formula that we have extended just now by putting the energy relation. Okay. So guys, remember, whenever there is a transition in which electron goes either from lower energy level to higher energy level, or from higher energy level to lower energy level, always we will use the relation is delta E is equals to 1 upon n1 square minus 1 upon n2 square z square, and have some constant, and that constant is what? 10966. Guys, look at this again, that I have just derived for you. See, 1 upon lambda is equals to 109,677 1 upon n1 square minus 1 upon n2 square into z square. Guys, see, this number is known as the Rydberg constant, which is represented by RH. This is represented by the RH, where R stands for the Rydberg and H stands for the hydrogen. See, R stands for the Rydberg and H stands for the hydrogen. So this one is known as Rydberg constant. Okay. So guys, we have to use this formula during the transition. Whenever electron makes transition from any orbit, that is lower to higher or higher to lower, we will use the formula 1 upon lambda is equals to 109,677 1 by n1 square minus 1 by n2 square. So guys, this is the Rydberg formula. Now tell me, is there anybody who has got any doubt regarding this concept? Anyone? Any doubt? Anybody want to ask me anything regarding this formula? Is it clear to everyone? You have to just write clear or not clear. Every center. Guys, till now, I think 3 centers shown their presence: Shillong, Senapati, Itanagar. Yeah, only 3 center, and Satna as well. What about other centers? Guys, every center will reply on the chat screen that whether it is clear or not. Do you need some other explanation? Okay, everyone is clear. Cool. Okay, Sisipu. So what is Z square? Dear, Z is the atomic number. Z is your atomic number. This is the atomic number. Sisipur, kindly write your doubt. What's your doubt? Kohima, are you there? Are you connected, guys? Kohima? Senapati, is it clear to you? Sisipur, write your doubt on the screen. What's your doubt? Guys, remember one thing, as I have told you that I am discussing some concept with you. At that time, you should be focused on the screen. If you're focused, you're connected with me, definitely everything will be clear to you. So, how came out 109677? Dear, you have to solve this one. 1 second. See, look at this. H has value of, just a second. Look at this one that I have circled you. Okay, that I have circled for you. Okay, look at this. Now, if I put all these values, let's suppose the upper value was 2.18 into 10 to the power minus 18, and the value of H is 6.626 into 10 to the power minus 34, and the speed of light is 3 into 10 to the power 8. So guys, if you solve this one, it will comes out to be 109677. Okay. Itanagar due to many text sent by default. Okay, it's okay, dear. Guys, now is it clear to everyone? Okay. So guys, first of all, you have to understand that how do we derive that Rydberg's formula. Okay. Second thing, where do we have to use that formula? Only two things. If these two things are clear to you, it means we are doing good. That's it. We have to understand these two things. These are two things, that where do we have to apply this formula and how do we get that formula? Is it clear to everyone? Is everybody clear with these two things that I have just discussed? Anybody? Anything? Shillong, raise your hands once. Is it clear to you guys? Shillong? Okay. The two students at the front desk at the Shillong. Okay, guys. Let's practice a question. Guys, I'll solve the first question for you. You have to visualize it clearly. Look at this clearly, what I'm trying to do. See, calculate wavelength associated with photon during the transition from n equal to 5 n equal to 5 state to n equal to 2 state. Okay guys, now let's take a look. First of all, you have to understand that we have to use the formula that 1 upon lambda would be equals to 109,677. 1 upon n1 square minus 1 upon n2 square into z square. Remember, this question is for hydrogen atom. For hydrogen atom. Dear, it is a constant. You cannot define the Rydberg formula, dear. Okay, you are asking about the Rydberg formula. Dear, how can you define the Rydberg formula? It is a relation, dear. When electron make transition from one energy level to another energy level. That is the Rydberg formula actually. So how can you define it? Okay guys, take a look for this one. Now, okay guys, first of all, we can change this number and we can write it like this: 1.09677. Oh dear, I'll discuss each and everything. You have to just wait for some time. I'll discuss each and everything. See, into 10 to the power 5. 1 upon n1 square minus 1 upon n2 square into z square. Okay. Now, see one thing. You can write this value as 1.1. Okay. This value can be written as 1.1. So, it will look like this: 1.1 into 10 to the power. It can be written like that: 1.1 into 10 to the power 5. Guys, remember, you have to use 1.1 just for the calculation purpose, nothing else. It won't give any big difference. n1 square minus n2 square into z square. Guys, next thing. How do we decide that which one will be n1 and which one will be n2? Guys, remember one thing. n1 will always be the smaller value and n2 will always be the bigger value. Always. That n1 will be the smaller value and n2 will be the bigger value. So, as in this case, this one should be n2 because this is the bigger value, and this one should be your n1 because this is the smaller value. Guys, have you got it? That how to decide the n1 or n2? Remember, n1 will always be smaller than n2. Okay? Now you have to just put the values and you have to solve it. See? Look at this. 1.1 into 10 to the power 5. 1 upon 2 square minus 1 upon 5 square. As we are talking about the hydrogen atom, so it will be 1 square. And this one is equals to 1 by lambda. So you can solve it for the lambda. Guys, now you have to solve it for me and you have to tell me the answer. You have to tell me the answer. Just solve it. Do it. And tell me the answer. Guys, tell me that is there anybody who has got any doubt, any problem regarding this one? That formula I have discussed with you. Anybody has got any doubt? Any problem? Quickly reply on the chat screen. Cool. We have got one answer. Nanometer. Let's see. Yeah. Guys, I'm waiting for your answer, dear. Solve it for me. Okay, Shillong. Satna, I'm waiting for your answer. Okay, you have given your answer. Itanagar, what's your answer? Shillong, okay, you have changed your answer again. Shillong, which one is your answer? The newer one or the older one? The last one. Okay. What about other guys? Okay. So guys, you have to just solve it. See, lambda would be equals to, guys, we have to solve it. Take a look. See, 1 by lambda would be equals to 1.1. Guys, remember I have not write any unit over there. To 10 to the power 5. 1 upon n1 square, which is 4 minus 1 upon 25. Okay. This is the centimeter inverse. The unit right now is centimeter. Okay. 1.1 into 10 to the power 5. Take LCM, you will get 21 over there, which is equals to 1 by lambda. So lambda would be equals to 100 upon 1.1 into 10 to the power 5 into 21. Okay. So this one will be 100 upon this one will be 23.1 into 10 to the power minus 5. So when you will solve it, it will be 4.34 into 10 to the power minus 5. Dear, unit will be centimeter. Okay. Unit will be centimeter. You can convert it into meters. Okay. So if you have convert this into meters, so your answer will be 4.34 into 10 to the power minus 7 meters. Guys, this is the answer. Okay. Even you can mention the unit over there. See, you can write unit over there. This one is centimeter inverse for right now. This is a centimeter inverse. If you write 1.09 into 10 to the power 5. See. Guys, you can do this one as well. This is 1.09 into 10 to the power 5 centimeter inverse. You can note this unit as well. Now tell me, is there anybody who has got any doubt? Guys, have you noted down? Have you copied this? Centers? Okay. Now, please tell me, oh, this is the solution for that particular question. Now, please tell me, is there anybody who has got any doubt regarding this question? Anything which is not clear to you? Anything? Tell me. That you want to ask me. Because next question that I'll give you, you have to solve it. The next question. Okay, Satna has responded, Shillong has responded. Kohima, are we connected or not? Sisipur? Itanagar? So, okay guys, can we proceed after that? If you have copied it, can we proceed? Or dear, tell me what you want to ask. Okay, I'll repeat this question for you. See, look at this. You have to use this formula. I have told you, just one second. You have to use this formula because I have told you during the transition, the orbit will be different. one will be N1 and one of them will be N1 and other one will be N2. Okay. I have told you that N1 should be smaller value and N2 will always be the bigger value. See, you will be given with the two orbits. Okay. Obviously, both of the orbits will have a different value for the transition to have got some wavelength or the frequency of the radiation. Okay. So pick up N1 as a smaller value and N2 as a bigger value. Okay. And after that, you have to just use the relation. Like in the given question, see, in the given question, they are saying transition takes place from n equal to 5 to n equal to 2 state. It means n equal to 5 is a bigger value. That's why I have taken it as a n2, and n1 will be n equal to 2 because this is a smaller value. What you have to do? You have to just put these values in this formula. Just put these values in this formula. See, I have put these values. Here, unit will be centimeter. Okay. Now, what you have to do? You have to just solve it. See, this is a 1 by lambda. After that, you will reciprocate it. See, this will transfer over there, and this one will be transfer here. So you will get finally that lambda should be equals to 100 upon 1.1 10 to the power 5 into 21. After solving all this equation, you will finally get this value. Any doubt? Any doubt? Anyone? Itanagar, is it clear to you now? Itanagar? Okay, guys. Here, the question for you. I'm waiting for your answer. Write down this question with me and you have to answer it. Calculate lambda, which is wavelength, for He plus ion during the transition from fourth orbit to second orbit. Guys, do it for me. I'm waiting for your answer. Guys, have you heard about the Shaktiman? Please, you have to solve it with me. I'm just asking you. Is there anybody who has heard about the Shaktiman? We have got one answer. Satna, have you heard about the Shaktiman? I think Satna is not interested in Shaktiman. Okay, then do this question. Guys, do it quickly. I'm waiting for your answer. Satna is very fast. Can you repeat your name again, Satna? Who's presented at the Satna Center? Yeah, Shillong is also there. Who is present at the Satna? Itanaga, have you got the answer? What's your answer, Itanaga? Okay, guys. So I think so. Everybody has attempted this question. So let's solve it. See. Again, we have to use the formula 1 upon lambda should be equals to 1.0. Okay, dear. 9677 into 10 to the power 5. 1 upon 2 square minus 1 upon 4 square into, as we are talking about the helium, so Z should be 2, it should be 2 square. So guys, what can we do? We can multiply this 2 square inside. See, we can multiply this with inside, or we can say we can take common from here. So if I take common from here, see, or you can solve it first, otherwise it will create confusion for you. 4 minus 16 into 4. Now, 1.1 into 10 to the power 5 upon 16. Here it will be 3 into 4. So 4 4s are 16, it will be cancelled out. So when you reciprocate it, it will be equals to 4 upon 1.1 into 10 to the power 5. Okay. Is there anything missing over there? Yeah, it is 3 as well. Okay. So when you solve it, you will get 1.21 into 10 to the power, this is a minus 5 centimeter. Very good. All those who has got the right answer, they can clap for themselves. Many congratulations. Shillong, as I can see you, you can appreciate yourself. Who has got the right answer? Any doubt till now, guys? Anybody has got any doubt that we have discussed yet? Itanagar, is it clear to you? Okay, dear, let's have a break. Okay, guys, let's take a break, a quick break of 5 minutes. See you soon. Hi guys, break is over now. Okay, so is everybody joined? Or still some students are outside? Quickly tell me. Is everybody ready? Sapna is yes. What about Shillong? Itanagar? Kohima? Okay, not yet. Guys, we have to start. Where have they been gone? Okay, who is missing? Tell me the name of those guys. Tell me the name of those guys who's missing right till now. Shillong Center, quickly. Who is still outside? Again. Okay, they are here. Okay. Okay, who came at the last? Who came at the last? The two students. Name of those two students who came at the last. At the Shillong. Yeah, guys, tell me the name of those two students who had joined at the last. Quickly. Okay. I'll remember these two names and will make sure that you will come at the right time. Okay? Okay, guys. So let's start again. So we were dealing with few questions. Okay? I hope so everybody has cleared with the question. Okay? So it is a new question for you. Okay? You have to solve it for me. Do it, guys. Calculate energy of photon during the transition from third state to first state. Okay, guys, let's solve this question first. Okay, then I'll give you another question. Guys, take a look. See, in the previous questions, we were dealing with the lambda, which is wavelength. Okay, see, this is the same kind of question, just I have changed one thing. See, we have to start with the basic formula that delta E is equals to minus 2.18 into 10 to the power minus 18. 1 upon n1 square minus 1 upon n2 square. Guys, as they're talking about the energy, we have to directly put this formula. That's it. Okay? So, put the values and solve it and you will have your answer. So, n1 will be 1. So, it will be 1 upon 1 square minus one upon 3 square. Okay, we are talking about the hydrogen atom, so Z will be 1. Remember, I haven't mentioned hydrogen atom. Okay, I'll mention it for hydrogen atom. Guys, remember one thing, whenever atom is not mentioned, it is by default hydrogen. It is by default hydrogen. So, we can get minus 2.18 into 10 to the power minus 18. This is 3 square 9. It will be into 8 by 9. So guys, you have to solve it and you will get your answer. Any doubt regarding this one? Any doubt? This is the joules. Okay guys, solve it for me and tell me the answer. Okay. Okay, Itanago. Guys, solve it and tell me the answer. I'm waiting for your answer. What is the answer? We have got one answer. Satna, is it the right answer? Yeah. Okay guys, so answer is 1.9 into 10 to the power minus 18 joules. Cool. This is the right answer. Congratulations to Shillong and the Satna Center. They have got quick answer and absolutely right answer. Okay. Other students may note down this answer and solve the next question for me. Guys, by the next question, make sure that the student at the center who has answered the first will write the answer with his or her name. Okay, guys? By the next time, when you solve the question, you have got the answer, you will write the answer along with your name. Okay? So, guys, this is the question number next for you. Calculate energy of photon for Li plus 2 ion in electron volt during transition from fourth orbit to, or you can write it 3. Third orbit to second orbit. Do it. Tell me the answer. Who has got the answer first will write the answer on the screen along with the name. Okay, guys, tell me the answer. Along with the name Sapna. Guys, got this answer? Okay, cool. Guys, do it quickly. I'm waiting for your answer. Shillong, Itanagar. What are you doing, guys? Okay, good. We have got another answer. Guys, last 30 seconds. I'm waiting for your answer. Last 30 seconds. Fifteen seconds left. Okay, guys, over. Okay, let's see. What is the answer? See, guys, in the question, it is saying that we have to calculate the energy in electron volts, and I have told you for the electron volt, you will use the value 13.6. 1 upon n1 square, n1 is 2, which is 2 square, means 4, minus third, means 3 square, which is 9. They are talking about the lithium. So atomic number of lithium is 3. So this one will be 3 square, which is 9. Now, 13.6 into, take a LCM of it. So 9 4s are 36. 9 minus 4 would be 5 into 9. You can divide it, it will be 4. So you have to solve it. Divided by the 4. 4 3s are 12. 4 4s are 16. Now, multiply it with 5. You will get 5 4s are 20. 5 3s are 15. Plus 2, 17. So answer will be minus 17 electron volt. Guys, any doubt regarding this question? Anybody has got any doubt? Is it clear to you guys? Congratulations, Sapna. Okay, guys, let's move on to next. Is there anybody who has got any doubt, who want to ask me anything till now that we have discussed till now? Should we move on? Guys, quick reply. Should we move on, or anybody wants to ask me anything? Quick. Okay. Shillong, what's your status? So guys, let's move on. Our next topic is hydrogen spectrum. So guys, this is our new topic, that hydrogen spectrum. See, uh, when we have done this topic, no dear, it is still continue. Actually, Bose model is not completed yet. It is still continue. It will take some more time. Bose model still. Hydrogen spectrum. This is another part of the Bose model. See, when the radiations emitted from the hydrogen, from the sample of hydrogen atom is passed through the prism and obtained on a photographic plate, we got some lines, some different lines. So, these lines results into a spectrum, a pattern, which is termed as the hydrogen spectrum. Now, just take a look. Guys, look at this very carefully. Nobody will note this right now. They will wait for some time. This is n equal to 1. This is n equal to 2. Guys, these are the orbits actually. N equal to 3, n equal to 4, n equal to 5. And this is n equal to infinity. Okay? See, what we are trying to do is, if electron comes from second orbit and finally jumps to the first one. Okay, if electron comes from third and goes to first, if it comes from fourth but comes to first, if it comes from fifth but finally lands on the first, or we can say it comes from any other state, but finally lands on the first orbit. See, this scenario was observed by a scientist known as the Lyman, that it doesn't matter the transition of electron starts from which orbit, but it should land, or its final destination should be first orbit. If this satisfies, if this condition satisfies, then we will say it is the part of the Lyman series. It is the part of Lyman series. So this one is our Lyman series. Okay? So guys, what I am trying to say is, doesn't matter from which state electron starts its transition, but finally if it lands, or we can say finally it reaches to first orbit, we will say it is the part of the Lyman series. Okay? Similarly, Let's take a look. If I say electron start its transition from third orbit, but finally goes to the second. For example, it starts from fourth and goes to second. It starts from 5 but goes to second. It starts from infinity but finally lands on the second. See, if this happened, then we will say it is a part of the Balmer series. B-A-L-M-E-R. This is your Balmer series. So again, this is identified by the scientist Balmer. This phenomenon was observed by the scientist Balmer. That's why we are termed as Balmer series. So what we have to remember in this case? Is that doesn't matter transition starts from which orbit, but finally transition ends at the second orbit. If this satisfies, it means it will be the part of the Balmer series. Now, let us suppose electron jumps from, one second, this is better. See, electron starts its transition from fourth orbit and jumps to third. Let's suppose 5 to third, and let's suppose infinity to third. So what we have concluded over here, that again doesn't matter from which state transition is starting, but it is finally ended up at third orbit. So if this condition satisfied, we will say it is the Paschen series. P-A-S-C-H-E-N. This is your Paschen series. Now, let us suppose electron starts its transition from fifth orbit and lands on the fourth. And again we can say it might start from the infinity, but finally it ends at fourth orbit. If this condition satisfies, we will say it is the bracket. B-R-A-C-K-E-T. This is the part of the bracket series. Now, again, if electron starts its transition, okay, hold on, I'll make one more line for you. This is n equal to 6. Now, look at this. Electron starts its transition from 6, or we can say from infinite, means any other state, but finally it ends at n equal to 5. We will say it is a P-Fund series. This is P-Fund series. So guys, this is what we call the hydrogen spectrum. So what we have to understand over here, that in hydrogen atom there are some series, okay, which depends on the type of transition, means which depends that finally where transition is ending. So if electron starts its transition from any state, but finally it goes to the n equal to first state, you will say it is a part of the Lyman series. If final destination is decided, which is n equal to 2, then you will say it is a Balmer series. If final destination decided is n equal to 3, you will say it is a Paschen series. If final destination decided is n equal to 4, you will say it is a part of the bracket series. If final destination decided is n equal to 5, then you will say it is a P-Fund series. Okay? So there are 5 series that you have to learn, and that depends on the condition that finally where the electron ends its transition. Okay? So it will depend on the N1. What is the value of N1? That will decide the type of series. If N1 is 1, it will be Lyman series. If N1 is 2, it will be Balmer series. If N1 is 3, it will be Parston series. If N1 is 4, it will be Brackett series. If N1 5, it will be your P-Fund series. Okay? So this is the hydrogen spectrum, dear. So anybody has got any doubt regarding the hydrogen spectrum? Ultimately, we have to understand that what is the final destination. That's it. That's all about this topic. So guys, quickly tell me, is there anybody who has got any doubt? Do I need to repeat this topic? You can note it down. You can copy it right now. Copy it, guys, and tell me on the chat screen, is there anybody has got any doubt? Any question, any query? Anybody wants to ask me anything? That's cool. Guys, I need response from every student and every center. Guys, remember, all these things are written in your notebooks, your school books, and many books that are available. But guys, we are meeting here. We are doing sessions over here. It has some meaning that we should understand. We should understand the concept clearly. Okay? That's the main motive of our sessions. So for that motive, you should clear each and every term. Okay? Okay, Shillong, I have got a response, Sapna. Itanagar, guys. Any doubt, dear? Any doubt, dear? Any guys? Any doubt? Any query? Any question? I'll explain one by one these series. Is everybody noted this? Everybody copied it? Okay, guys. So let's start. Let's continue with the hydrogen spectrum. See, the first one was Lyman series. See, in the Lyman series, N1 will be fixed, which is 1. But N2 will not be fixed. N2 can be your 2, 3, 4, 5, up to infinity. It can have any value. And remember, this lies in the UV region. Okay? UV stands for the ultraviolet. Okay? UV stands for what? Ultraviolet region. Now, number 2, which is Balmer series. Balmer series. So Balmer series, N1 will be fixed, which is 2, but N2 will not be fixed. For the transition, it should be greater than 2, so it can have value 3, 4, 5, 6, up to infinity, anything. And guys, remember, this belongs to the visible region. Visible region. Okay? Now, next is your bracket. Next is your Paschen. Guys, you have to remember the radiations as well. In which radiations these are belonging actually. So here N1 will be fixed, which is 3. But N2 is not fixed again. It can have value 4, 5, 6 up to infinite, anything. Okay. This belongs to infrared region. This belongs to the infrared. Infrared. Where in infrared? Near. Next, bracket. In the bracket series, N1 will be 4, but N2 can have other values 5, 6, 7, 8 up to infinite, anything. And here the region is again infrared, but it lies in the mid of the infrared region. Now the last series that we have to discuss is P fund. In the P fund series, N1 will be 5 and N2 can have value 6, 7, 8 up to infinite. And here again the region is infrared, but it lies far. So guys, this is the summary ultimately that we were discussing just previously, that what we have to remember is from where Lyman series starts and in which region does it belongs. Similarly, you have to remember it for the Balmer series, Paschen series, bracket series and the P fund series. Guys, copy it right now. Copy it and tell me. And tell me, is there anybody who has got any doubt? Anybody has got any doubt regarding this concept? Yes, dear. IR stands for the infrared. IR stands for the infrared. See, this is your infrared. Dear, IR is the infrared region. Infrared radiations. I hope so. You have heard about the word infrared. Okay, cool. Itanagar, I have just told that IR stands for the infrared. Look at this, dear. I have just written it for you. See? Look at the screen. IR stands for the infrared. Any other problem, any other doubt, any other query, anything that you want to ask me? Infrared is a radiation For example, you have radio waves. Have you heard about the radio waves? On which frequency radio stations works? Similarly, infrared is also a type of radiation which has a different use. Okay? There are many radiations, for example, ultraviolet, infrared, visible, microwaves, gamma rays, X-rays. These all are radiations actually. On the basis of their frequency and the type of wavelength, they have different uses. Okay? Is it clear now? Shillong? Okay guys, do one thing for me, that by the next time, okay cool, that's clear. By the next time guys, along with your doubt, kindly write your name. Along with your doubt, kindly write your name. Is it possible? Can we do that now? Yeah, that's fine. Cool. Okay guys, now tell me one thing. Seriously. Is there anybody who has seen Shaktiman? This one. Anybody knows about this guy? Have you heard about it, Shaktiman? Yeah, sir, seen. Any other? Guys, I'll show you Shaktiman. First of all, tell me, how many of you know about the Shaktiman? Shillong, have you seen the Shaktiman? Or is it first time that you have heard this name? In the movie I have seen. Okay. Okay. See. This is the Shaktiman. First of all, tell me, is it Shaktiman or not? Wait. Just a second. Tell me, is he Shaktiman or not? There are many fans of Shaktiman. Is it Shaktiman? Yes. Yeah, actually Shaktiman is flying. He is rotating actually. Because this is the Shaktiman. Actually, he look like this. He flies like this. And after the rotation, see, he rotate in this manner. After the rotation, he become like this. Is it true? New theory. Shillong. Am I right or wrong? Yeah. Satna, what are your views regarding this one? That yes, Shaktiman will look like this after rotation. I mean, when he tried to fly. Okay. So guys, that's all about for today's session. Okay, we have done with this. So it was nice time with you guys. Make sure before the next class you will revise it completely, thoroughly. Okay, so we can continue with that. And if you have find any doubt regarding the concepts while you revise, you can ask me in the beginning of the class next time. Okay, so guys, take care. Bye bye. Have a great day.